Let's start with creating of two actor, one, for the shield, another, for the target. Go to the Mesh tab, we need to create a socket on the left hand for the shield. Let's add our shield as a preview asset to make it easier to set the socket. Now we need to set up links to the shield and target. For the tutorial I'll do it with a pipette, although in a real project it's better to do it in another way. I copy the algorithm fast grab in order to quickly attach the shield to the newly created socket. I also want to note that idle animation must be suitable for the shield. In order to be able to use IC functions for a hand, we need to call a special function and make a setup. You need to do this in the Begin Play tab. For now, let's do this for the left hand only. Although we can certainly make setup for any number of hands, even if there are more than two. Forward vector should be in the component space and point to where the elbow is pointing. In our case, the elbow indicates purely the y-axis. Therefore, the vector will be equal to 0, minus 1.0. Anchor size is the size of the anchor. The larger it is, The more tightly the arm is stiffen movements. Also, there are parameters for determining the time of transition during hand movements. The rest options are still the default. Specific data. This structure is needed to set basically the parameters of the body. Body forward vector is the vector indicating the direction of the body rotation in the component space. We could also set offsets to the rotation and position. These offsets could be applied to the previously specified spine bone, as well as to body forward vector. Next, separate parameters define the boundaries of the hand movement, how far the hand can move according to the UC algorithm with respect to our vector, the parameters of which we specified earlier. Forward moving. The structure is needed to move the arm forward or backward when moving the arm in the indicated directions. Let's set X as an axis along which the arm will move. While moving along the X direction, the arm will be moved forward. While moving along the X-axis, it will be shifted backward with respect to the body. We'll analyze it in more detail later. Orientation is a structure for more detailed orientation settings for both hand and upper arm. The first two parameters are needed to set the hand rotation intensity. Further, three parameters define the upper arm rotation when the target is above or below us. The following 5 parameters set an additional upper arm rotation, provided that the hand moves in the direction we set. We can also set the init rotation for upper arm. Set the parameters as I showed, then we'll analyze it in more detail. Now we need to calibrate the hand. Hand index is the number of the hand in array. Now we'll call the functions directly implementing the UC algorithm. With the help of clamp direction we can set limits for body rotation angles. If target goes beyond the limits, the IC algorithm will be reset. Turn off Solve Upper Arm for a while. We will disable the extra rotations that we set earlier for upper arm. Let's calibrate the hand so that it's focused as precisely as possible on the IC target. We need to come to the target at different angles and take a look at the result. Don't forget to remember the best result. Next, enter the calculated value in the initial delta hand rotation field. Now I'll tell you about specific data in more detail. As you can see, the white arrow with the debug enabled indicates the body vector. This vector comes from the spine bone in the direction of the body forward vector. I'll add a little turning. And also I'll raise it slightly. Now the vector is better correlated with the animation that we have chosen. It's important to remember that all movement limits are calculated with respect to this vector. It's important to understand the difference. Side limits precisely limit the movement of the hand, but the clamp direction in the function for actor completely drops the IC. Now I'll slow down side moving limit a bit. The character now won't move his hand so far in the side directions. Let's study out the forward moving more detailed. If we adjust the left hand, it's necessary that when moving it to the right, that is, in the direction of X, it's necessary that it moves slightly forward. If this is not done, then the hand may fall through the body. Green arrow indicates in which direction the hand should move in order to start the forward moving, while blue is for backward moving. It can be seen that the hand is shifted slightly forward when moving along the green arrow. Now I will play around with the forward moving parameters a bit. Backward moving is the same thing, but here the arm moves back towards the body. Let's study out the orientation structure in more detail. Freehand rotation applies a slightly different algorithm. Rotation power adjusts the degree of the hand rotation to the target. In it, rotation upper arm is needed to adjust the algorithm for a particular animation more precisely. Solve upper arm is needed to simulate the turn of the shoulder in addition to rotation and movement of the hand. Don't forget to tick the solve upper arm, otherwise it won't work. Apparently the character now began to cover itself with a shield. If the target is above, it uses turning in upper arm. Solve negation is needed to turn the shoulder when the target is below the character. You can also set an additional upper arm rotation, if you move your hand, for example the movement of your left hand to the right and making a turn with regard to the x-axis by 90 degrees. Specific data can be set for a specific animation. Select the desired animation and set up your own data for it. These functions are used for pause or stop tracking the target. It's also possible to change the transition time settings. In addition to the target actor, it's possible to choose not actor as a target, but simply a position in world coordinates or an offset. I also want to show an interesting macro. It will simulate the movement of a hand and its further return to point 0. This macro uses exactly the offset task and returns the hand to its original position after delay. It's possible to complicate the macro to make more complex movement. Now I will set the offset and let's take a look at the result. Now we have the shield slam, which is the fully procedural algorithm.